And because with sickle cell disease, sickle cell is multifaceted, all right? Even though it is a genetic condition, okay, it's a recessive disorder. And one of the things about recessive disorders are the ones that usually you don't want to have, okay? They're definitely more common, all right? But what happens is it changes the shape of the red blood cell. And here's what happens. Blood is supposed to flow freely, right? You get this sickle shape, it gets stuck, okay? It'll get stuck in, like when we get to the capillary area, it can actually be in the smaller vessels, okay? And because of that sickle shape, if we're trying to flow through a vessel, it'll get stuck. And that means it can occur to any area of the body. People can be affected with their eyes, their digestive systems, their liver, their muscles, okay? So this is a multifaceted disorder. And it happens because of the 6th amino acid on one of those beta chains. Do you remember for hemoglobin? We had 2 alpha, 2 beta. The 6th, now remember, amino acid, amino acid, amino acid, amino acid, strung together is what is going to make the protein. And at number 6 on the beta chain is what causes this debilitating disorder. That's pretty amazing, that they have been able to research it down to that point. Now, it's come a long way, all right, with the research. However, it's still a debilitating disorder for people who suffer from it. The clumping occurs, we get the blockage in the blood vessels. It can lead to stuff such as heart failure, stroke, paralysis, and the belief, I guess the research, the theory behind it is that it developed in being exposed to malaria, because people who have sickle cell don't get malaria. They're resistant to malaria. So there's a lot, and that's only a few. That's only a few of the problems that can go wrong with the red blood cells. Now, for the blood type, I keep saying I can't donate blood because I'm anemic. And so, but I keep saying I'm going to go back because I don't know my blood type. So I asked my doctor, I was like, can you get my blood type? Well, we don't do that. You need to go to like Virginia Blood Services, donate blood, and let them tell you your blood type. Seriously? I guess it's some kind of major issue to get your blood typed. But why would it be important to know your blood type? What? In the case of a transfusion, definitely don't want to be given the wrong blood. Because if you're given the wrong blood, what happens? Well, I was kind of thinking what happens in the actual vessel. Okay. However, yes, and what happens is it clumps in the blood vessel, and you don't get the blood flow to the tissues. Now, it's important, of course, when you think that there's going to be a blood loss, so like if you're going to go have surgery, for example, you can do a thing where they bank your blood for you, All right, it just depends on what you want to do. When early transfusions were done, where literally one person was on one table, one was on the other, and they had a tube between them, okay? They found that these reactions would occur and it could end up in death. Now, as we have moved forward and as we have learned more about the blood, and especially learning about the structure of the membrane, okay, we have come a long way in blood understanding. We need to make sure blood types and transfusions, okay, that we're extremely compatible. And we need to be more compatible than simply A, B, or O. All right? A, B, O. But we also have A positive, A negative, B positive, B negative, AB negative, AB positive, O positive, O negative. See where I'm going with this? All right. So now they have learned, okay, to get it down to the point where they know to give you maybe A negative or A positive. Well, if you watch like the emergency shows and stuff, one thing you'll hear them do, cross and type the blood, all right, if we don't know it. And they're checking to see, is it positive, is it negative? Why is that important?
Because if you give a person with positive blood, negative blood, or negative people positive blood, they don't have that RH factor, so
it can cause issues. Now, what we know, okay, because this is going to be based on the structure of the red blood cell, what's going to be present on that plasma membrane. There are definitely complex molecules on the surface of that membrane, and they can activate an immune response. If your body thinks that something foreign has entered it, it wants to fight it. And being given blood is going to be something foreign that it wants to fight. So, the molecules, genetically unique to the individual, need to distinguish the self, your cell, from something that might be foreign. And if so, take care of it. If something foreign enters the body, that immune response is going to kick in. Antigens on the surface for blood typing, we term them agglutinogens. In the blood groups that we have, we think of the blood groups A, B, and O. We have over 100 blood types. A, B, and O are the most common. The others, extremely rare. Extremely rare. Now, the ones that we tend to deal with the most are going to be the A, B, and O. So, when we have the the response to a foreign matter entering the body, we're going to find that in our immune system, we have plasma cells. Those plasma cells produce proteins. Because it's the immune response, they're known as gamma globulins. They play a part in the attack of the foreign matter. Their job: bind to the antigen that is foreign, mark it for destruction. Therefore, when this protein, known as an antibody, gets made and it attaches to an antigen, it's termed an antigen-antibody complex. Agglutinins, different from the other slide, okay? Agglutinins, those are going to be antibodies in the plasma that tell us the mismatch for the transfusion. When something agglutinates, agglutinate means clumped together. Not good. All right? This is what happens. Agglutination. Something agglutinates. If we look at this that takes place on our red blood cells, what do you notice over there about O, B, A, and AB? When we look, because we are looking at something that is on the membrane of the red blood cell. So these groups that are existing on the red blood cell, those are helping with the identification. So, the antigens for the red blood cells, those are the agglutinogens. All right? They're termed A and B based on a glycolipid. Glyco, sugar, lipid. What's the lipid portion? What's the lipid portion of this? What is the membrane of my red blood cell made of? Phospholipids. This sugar chain is existing from the phospholipid bilayer. Does that make sense? So now sugars that are extending from the phospholipid bilayer, their structure is letting me know O, B, A, B. Yes, no, maybe. Antibodies are my agglutinins. They are going to be in the plasma because they're from the plasma cells of the immune system. They are termed either anti-A or anti-B for the antibodies. So, if I'm in my blood vessel and I've got my red blood cell, and if my red blood cell has the markers that it's supposed to have, which one is it? Is this an antigen or an antibody? This is my antigen. Now, antibodies are going to be found in the plasma of the blood. Yes, no, maybe? So these are my antibodies. Okay? Does everybody follow me? So, if you look at your blood type, it's determined by either the presence or the absence of an antigen. Blood type A has A antigens, B, B, AB has both A and B, O has none of them. The most common blood type, O, the rarest, AB. This is sort of how they type it. They simply take a drop of blood, put some chemicals on it, check to see if clumping occurs or not. So, type A, they expose to the anti-A, anti-B, clumping, no clumping. So that lets them know that they're type A blood. And on down the line. Type O doesn't clump in either one of them.